Welcome to section 5.1, Boolean expressions and if-else constructs. In this lesson, we'll explore how to use Booleans and conditional logic to make decisions in Java. Our objectives include declaring and using Boolean variables, comparing expressions, and using if and if-else statements effectively, including comparing strings the right way. Java supports several data types. One of them, which is Boolean, helps us add logic and decision making to our programs. Let's visualize that decision making. Imagine standing at crossroads, choosing which way to go. That's logic in action. Suppose you're driving to school and stop at an intersection. You must choose left, straight, or right. Each choice is a yes/no question, just like Booleans. Java's Boolean type uses true and false instead of yes or no. You declare a Boolean variable using the keyword Boolean. Here's an example. We declare and assign Boolean values and then print them. Remember that a Boolean data type can have only two possible values, true and false. Note, true and false are never enclosed within quotes because they are Boolean values, not strings. Output of the example shown in the slide is true, false, true. Let's expand on this with a GPS analogy. If you're navigating to school, which direction should the GPS take you based on what's true? Here is a simple code example. Depending on which Boolean is true, the GPS declares which way to go. In this case, go straight ahead is printed. Based on this simple code, the car will go in the direction that has a Boolean variable with a value of true. Note, enhancing this example with more code will be covered further in this lesson. Just like math expressions, Boolean expressions can be printed or assigned to variables. The result is either true or false. Here we see a Boolean expression being printed and also stored in a variable. Use the equal sign, a single equal, to make an assignment and use the double equal sign to make a comparison and return a Boolean. The double equal sign operator is used to check equality. It returns true if both sides are equal, false otherwise. The single equal operator assigns values. When used with a Boolean expression, the result of that expression can be stored. You can compare literal values or variables using double equal sign. In both cases, the result is a Boolean, either true or false. Here is another look at the same expressions. The result will be false because 24 is not equal to 50. Relational operators expand what you can test for in an expression, greater than, less than, and so on. Here are the common relational operators: double equal sign, not equal sign, less than, less or equal, greater, greater or equal. Each compare values and returns a Boolean result. The table lists the different conditions that you can test by using relational operators. The result of all relational operators is a Boolean value. All of the examples yield a Boolean result of true. Here is a code example using relational operators. This prints out several comparisons between two variables. Equality testing: for objects, use the equals method for testing equality. The output will be, in this example, false, true, false, true, true, false. In exercise 1, you will create a program to check if a user's age is under 18. Based on that, set and print a Boolean result. Conditional statements like if and if else let your program choose what to do next based on Boolean expressions. An if statement checks a condition and runs a block of code if the result is true. Otherwise, it skips the block. The condition to be evaluated is surrounded by parentheses. It's referred to as Boolean expression because it must evaluate to either true or false. In this flowchart, we see how a true condition leads to an executed statement. A false one skips it. In the slide example, the Boolean expression in the second if statement returns true. Therefore, drive straight is printed to the console. In example 1, you want both statements to be executed when the condition is true. Because there is no code block, only the first statement is executed. In example 2, both statements are executed when the condition is true because there is a code block for the if statement. To avoid this error, you must use code blocks even if there is only one statement to execute in the if block. In the slide example, there are two if statements. The first tests for values greater than 88. The second tests for values less than or equal to 88. Both if statements are evaluated, even if the first one is true. In exercise 2, you will test whether a number is odd or even using if statements and modulus. Use if-else when you want your program to choose between two alternatives. If one is false, the other runs. The if-else statement is one way of branching your code depending on some condition. It uses two Java keywords, if and else. If some condition is true, execute the code within that if block. If that condition is false, execute the code in the else block. This flowchart shows how an if-else structure splits behavior depending on the Boolean result. Here is an example. If the temperature is less than or equal to 32, the forecast is snow. Otherwise, it's rain. This slide demonstrates an if-else example. The getTemperature method returns the temperature as 30.3. Because the temperature is less than 32 degrees, the Boolean expression, temperature less or equal to 32.0, returns true, and the if block is executed. Here's another version. When the temperature is 40.2, the condition is false, and the rain block is executed. This slide demonstrates if-else example. The getTemperature method returns the temperature as 40.2. In the if-else statement, since the temperature is less than or equal to 32 degrees, the Boolean expression, temperature less than or equal to 32.0, returns false, and the else block is executed. This example shows how if-else is more efficient than two separate if statements. It only evaluates one condition. In exercise 3, find and fix logic problems in the ageCheck.java file. Replace two ifs with an if-else structure. In exercise 4, use an if-else block in shoppingcart.java to change the message if the item is out of stock or if quantity is greater than 1. When comparing variables, be careful. Double equal sign works great for primitives, but is unreliable for strings. Here's why. Primitives are stored by value, so comparison with double equal sign works correctly. But strings are objects. Comparing them with double equal sign checks memory locations, not their content. Primitives like int compare fine with double equal sign, but strings require a different approach. To compare the content of strings, use the equals method. This checks whether the actual characters match, so that the value of test would evaluate true. When upper and lower case do not matter, you can use equals ignore case method. In exercise 5, check whether a user's input equals mo. Use equals method, not double equal sign, to avoid logic errors. To summarize, you've learned how to declare and use Boolean variables, compare values with relational operators, use if and even statements, and properly compare strings.